How many of you feel uncomfortable? Our experience of every day relies heavily on the existence of light. Imagine a life with no light. Crazy, right? Yes, I'm going to ask you to do the opposite. Try to imagine light. Can you? Guys, what is light? Light is this crazy thing that's always there, but is it? I mean, you certainly can touch light, you can see light, you see because of light. So how does it all work? Interested? Well, you guys are like, in the next 5 minutes, I will define light, I will explain what this cryptic concept is, and it will help you understand how the human eye is able to see the world in colors. So let's get started. According to Steve Stannard from Edison International, what we define as light really is just a very small part of the electromagnetic spectrum, which refers to the many types of radiations released from stars, like the sun. What you need to understand is light travels in waves. So according to Dr. Survey, author of the book Principles of Physics, wavelength is the distance from the peak of one wave to the peak of the next wave, and it is used to measure different types of wavelengths. So longer wavelengths are called radio waves, and these can be as long as football fields. Okay, then microwaves, these are about an inch long, and they are used in telecommunications, radars, and of course cooking. Then we have infrared radiation, which is responsible for heat. Humans can't see this, but snakes, for example, can. What we can see is this little part right here, which we call visible portion of the spectrum. Now, if we were to extend the whole spectrum from LA to New York City across the country, the visible portion would be just about 1 inch. Well, that inch, my friend, is what we call light. Even shorter radiations are ultraviolet and X-rays, which we all know. And then, even shorter than that are gamma rays, which are so small and energy charged, they can literally destroy the atoms in your DNA. In fact, think, atomic bomb. Okay, now that you understand what light is, we can use the concepts we just learned in order to get ready, shed some light on what colors are. Okay, Dr. Pekefew from MIT explains that different wavelengths within the visible spectrum are perceived as different colors. Now, the shortest wavelengths within the light range are perceived as violet, and the longer wavelengths gradually appear as blue, green, yellow, orange, and finally red. Okay, but some of you may still wonder, why do we see colors in the first place? Well, according to Sir Isaac Newton, who he discovered in 1666 that some objects, like the sun or a light bulb, produce light. We call this white light because it combines all of the wavelengths of the visible spectrum, which appear as white. This can actually be proven with a pretty easy experiment. It's called the prism experiment. What we're going to do is we're going to shed some white light through this prism, and different wavelengths are going to bend at different angles, therefore separating the colors that are within the white light. And this should generate this sort of rainbow that, since I'm just using an iPhone, it's not that cool. But the point is, why is this important? Well, Dr. Nassau, he is a research scientist, explains that when white light hits objects, these objects absorb all wavelengths but one. So this specific wavelength cannot be absorbed, so it's reflected. Guys, this red cup is not intrinsically red. It just happens to reflect radiations that are about 700 nanometers long back into your eye, which has a black pupil, so it's black, it absorbs all wavelengths. So the radiation is absorbed by your pupil, it's projected into your retina, where some cells called cones send a message through the optical nerve back into your brain, which finally interprets the information as the cup is red, indeed. Got it? Okay, so let me give you a recap of what I went over today. First, I explained what is light and defined it as a type of radiation. Then I explained what are colors, how our brain is able to see them, and demonstrated it to you with a prism experiment. Okay. What about clear stuff? I will leave that one to you guys. Go home and research more on this amazing topic. And remember, this is science. It is just the way it is. Thank you.